Hello, year four. How are you guys? At the beginning, I just want to thank you so much for the beautiful, beautiful pictures that all of you sent me. I'm still waiting for the rest of you guys to send me some pictures of the activity that we agreed on. I did my homework too, and I did some activities to help you understand the definitions that we have said in this lesson. So we're going to start with mass versus weight. So this is my daughter's bag, and I'm going to fill the bag with a number of books until it's completely full. And this is the exact definition of mass. It is the amount of matter in an object. In this case, the object will be the bag, and the matter is going to be the books that I'm filling the bag with. So in this case, after filling the bag with all of this of the books, the fact or the number of books will never change even if I took this bag to the moon. So the mass of this bag will remain the same. If I am on Earth, if I am in the moon, if I am on Mars, it will never change. And this exactly why the mass of an object never changes. Your mass never changes even if you traveled anywhere. So this is because the number of matter inside you will never change. You're still the same. So the mass is not a force, it's just the number of matter or the amount of matter inside an object. Now, after closing the bag, I will try to hold it up, but here comes the force part. The gravity force always trying to pull back the bag to it again. So this is what gravity is, and it changes from a place to another because the gravity on Earth is different from that on Mars, is different from that on the moon. So that's why the force of gravity or the weight, is different from one place to another. Now I'm going to show you how friction works. So I have those my daughter's roller blades. So I'm trying to push one of the roller blades on the carpet and the other on the tile. See what happens? I pushed it, of course, with the same force as much as possible. You will find that the friction force between the roller blades and the carpet was higher than that of the tile, and that's why it moved easily on the tile. Now there's an activity in page 12 that I'm going to upload it for you in the other video, and I tried to make the activity. I'm going to try move this car, this little truck on a metal surface, and then I'm going to measure the distance that the car moved, and after measuring it I found out that it moved for, let's see together, I think about 13 centimeters. So I'm going to record that on metal it moved for 13 centimeters. Now I'm going to try it on a different surface. This time I'm going to try it on the carpet, and I'm going to mark the starting point using a pen so that I can know where the truck started from. And I'm going to push it as much as possible with the same force that I did on the metal surface. And then I'm going to measure the distance that the car moved. It was about 9 centimeters. So I'm going to record that the distance the car moved on the carpet surface was 9 centimeters. Now I'm going to try the third surface, which is the tile, and again I'm going to use my pen as a starting point for the car, and I'm going to push it, and then I'm going to try measuring the distance between the car and the starting point, and it's going to be about 17 centimeters. So I'm going to record that it was about 17 centimeters. Now the last surface is the wood surface, and I found at my house a wooden box I'm going to use. So I'm going to start from the edge of the wooden box. I'm going to push it, and then I'm going to measure the distance that the car moved. And actually it was about 9.5, but I didn't notice because the car moved a little bit backwards. So I'm going to record it this way. It's about 9.5, but I'm going to, as because in this video or in this trial it was 9 centimeters. So I recorded all of my results. Now we're going to learn about the upthrust. I got a small bowl, empty one, and then I put it in a larger bowl filled with water, and I'm trying to push the ball down the water. You will find that the water is resisting and it keeps pushing back against me. As you can see, this is the last time. Yep. Now I'm going to show you the difference between the streamlined boat and the wide boat. I made just paper boats, but one of them thinner. It's just the wideness of it. I made it thinner than the other one. So this is the streamlined boat, and this will be the much wider boat. Can you see the difference? And I'm going to put both of them in the water, and I'm going to make a little race. I pushed the first one, the wide boat, and I pushed the second one. You will find that the streamlined boat did not find much difficulty to move in the water. That's it, guys. I hope you learned from this activity. If you have any questions, just send it to me in the Google Classroom comments. And I'm still waiting for the rest of your pictures, guys. Thank you very much. It was very fun watching you guys. I missed all of you, and I hope you're all staying safe. See you, and bye-bye.